Dear students, welcome and thank you for tuning in to this video. I'm still doing the key solution for exam 2 of statics and dynamics, problem number 2. It is going to be about the support reaction forces. So this is the problem. We would like to determine the horizontal and vertical components of reaction forces at pin A, the smooth pin A or hinge A, and the reaction forces or at the rocker force at the rocker B on the beam shown to your left. You need to draw the free body diagram. Step 1 in this analysis is actually drawing the free body diagram. So let's do it together. So I'm going to draw the beam from A to B. I need to be much more precise in my drawing. At point A, I'm going to use different colors for the reactive forces, so support reaction forces. So let me use blue. In the blue, at point A, this is a smooth pin or a hinge. It is preventing translation in the x-axis, so I'm going to assume a reactive force AX on the x-axis. Also, it's preventing translation or movement on the y-axis, so I'm going to create a reactive force and assume it to be AY at these points. At point B here, we need to pay attention because our reactive forces should always be perpendicular to the surface that they are acting upon. So if you look at this surface here, the surface is actually preventing the rocker and the beam from going in this direction, right? And moving in that direction. So my force has to be, this. I would draw the surface, right? And my force is going to be perpendicular to that surface. So I'm going to assume a reactive force like this. Now, this reactive force, we don't have to put it a Bx or By or whatever. It's just B. That's my reactive force, right? So this is very important. Your reactive force should always be perpendicular to the direction of movement or the surface. So if you can see that the Ax, the direction of movement or the surface that the pin is preventing is this surface, which means that AX is perpendicular to that surface. Let me just draw it in a different color just to show you what do I mean by that. So let's do green. So AX, the pin is preventing movement, from here to there, right? And that's why I have my AX perpendicular to that axis. So that's AX. Same thing should happen here. I should have a surface that's preventing the translation or movement in that direction. So I will place my force B to be perpendicular to this surface. That's what I need. Now, how many unknowns do I have? 3. It's very important. Also, I need to add, in a different color, I need to add actually, let me do black. I need to add my external force, which is the 4 kilonewtons. So this needs to be placed here. So that is your 4 kilonewtons. And this is my free body diagram. And it's 2 meters from point B and 6 meters from point A. If you draw this free body diagram, and there's one more step that need to be completed. So B, it needs to be, in order to have a complete set of, to simplify our analysis, we need to resolve B into X and Y components. So what I will do, I will just draw the axes. This is the Y axis and this is the X axis. And if you know from the analysis, from the question above, we know that this is 30 degrees. And from trigonometry, I know that the angle with the Y axis here is 30 degrees. So I can resolve B now into 2 components. So let's resolve them in different colors. Let's do the, a blue. Oh, let's do magenta, right? Color. So B, this is 30 off the y-axis. So this force here is going to be B cosine 30. You don't have to put Bx or By. That's fine. And also I need to resolve this on the x-axis here. That force is going to be B sine 30. Remember, I'm using this angle here, right? So cosine, sine, so those are my 2 forces. The forces resolved from force B. If you have all of these in place, you will get 1 out of 4 points. So that's your first point, drawing the free body diagram. And we are all good. Alrighty, so now let's do the analysis. So to do the analysis, we are going to construct our equations of equilibrium. And as if you recall, summation of forces on the x-axis should equal to 0, summation of forces on the y-axis should equal to 0, and summation of moments around the point should equal to 0. And I'm going to select that point to be A, because as we agreed upon, we will select the point with the largest number of unknowns. And the largest number of unknowns is ax and ay, so I'm going to use that point. And this should equal to 0. Your direction notations: to the right for x is positive, up for y is positive, and counterclockwise is positive for the moment. So let's start with the moment first. So the summation of moments around point A, counterclockwise is positive, should equal to 0. We are at equilibrium, which means the reactive forces AY and AX, they pass through the point A, which means that they're not going to create any moments. So let's do the 4. The 4 kilonewtons is going to rotate clockwise around the point, so there will be -4, and the distance between the line of action of the force and the point A is 6 meters. Also, I have an x-axis component for the B, which is B sine 30, but if you notice, it passes through point A, so we don't have a distance, so that's not going to create any moments, so that's gone. I have the y component, which is B cosine 30, and if you notice, it's going to be rotating counterclockwise, so it's going to be positive B cosine 30. Don't forget the distance between the line of action of the force and the point A, which is 6 plus 2, that's 8. I don't have any other forces, that equals to 0. Right? You can move the -4 multiplied by 6 to the other side, so you will end up with B and divide by cosine 30 divided by 8, so this is going to B is going to be 4 multiplied by 6 divided by 8 multiplied by cosine 30. Right? And this is going to give us the value of B, the force, to be 3.46 kilonewtons. If you have that, B, you are going to get 1 point out of the 4 total points of the problem that we are solving. So I have my reaction force now. The first reaction force, which is B, at the rocker that we have there. Now, I need to continue my work to find AX and AY, so I will use the other 2 equations of equilibrium. So I've used the first equation of equilibrium with the moment, so let's use the AX and the AY. So, summation of forces on the x-axis should equal to 0, to the right is positive. So if you recall the free body diagram, I have AX. So let me draw them in a different color so that we can distinguish between them. So let me use blue. I will do here, that's your AX, that's AY. B, I have here a B, which we said that it is B cosine 30, right? So this is going to be 3.46 multiplied by cosine 30, and on the x-axis I'm going to be 3.46 multiplied by sine 30. And I have this is all the forces that I need. Let's go back to our analysis. I will change the color to be black again. So here in the x-axis, what do I have? I have AX positive. I have negative 3.46 multiplied by sine 30. Do I have any other forces here? No, that equals to 0. I can find AX. So from this AX, you can move the minus 3.46 multiplied by sine 30 to the other side. It becomes positive. So AX is going to be 3.46 multiplied by sine 30, and that equals to 1.73 kilonewtons. If you have that correct, you will get your point, 1 point out of 4. Now let's do the summation of forces on the y-axis. Up is positive. What do I have on the y-axis? I have AY positive. I have minus 4 kilonewtons. It's going down, that's negative. And then I have plus going up 3.46 multiplied by cosine 30, right? And all of these equal to 0. You can move this to the other side, this to the other side, change their signs. So you have AY equals 4 kilonewtons, right? Minus 3.46 multiplied by cosine 30. And this is going to give you AY to be 1.00 kilonewtons. And if you have that, you get another point out of 4. And that's it. This is all your reactive forces. So the first reaction force was the one that we found B before. So if you want to put them all together here, your B equals 3.46 kilonewtons. And again, the free body diagram is 1 point. This is 1 point. It's 1 point, 1 point. So you have 4 points now. I hope that this is helpful in understanding how to find the reactive forces created by support reactions, which is, the smooth pin and the at A and the rocker at B. Thank you for watching. Until the next video. Bye.